Hi, my name is Joey Legrand. I'm team lead for Team CodeRx, presenting Medication Diversification Tool, which is our Phase 2 submission for the Synthetic Health Data Challenge in the Enhancements to Cynthia Pediatrics category. One of the first things that Team of 6 PharmDs noticed about Cynthia is that the output of medication is overly simplistic. When we look at pediatric asthma patient population, 100% of these patients get the same exact maintenance inhaler, as compared to MEPS, which is a nationally representative survey of patient usage of medication, in which only 34% of the same age range gets that product and everybody else gets different products. The product in question is a inhaled corticosteroid, and it's one of many different types of the same product ingredient. They're all single ingredients as opposed to combination therapies, which have multiple ingredients. And they come in 3 different dose forms: metered dose inhaler, dry powder inhaler, and inhaled suspensions. This type of information can be easily available in guidelines or by working with clinical experts. And it's the challenge for a medication diversification tool to easily allow a developer to convert this information to a usable Cynthia module that outputs realistic and diverse medications for synthetic patients. So the first step is to clone and install the repo that we've put on GitHub, open source, and then it's the job of the developer to fill out some relatively simple settings. The first of which is what medications we're targeting. You can either use Rx class, which is a National Library of Medicine service, to pick a class of medications or pick individual ingredients. In our case, we simply searched for corticosteroids in Rx class and got a list of medication ingredients. This also comes with an ID and a class type, which we can be easily input into MDT right here. If you know individual ingredients, you can import them here into the Rx GUI field. The second thing is we know they want inhaled corticosteroids, so we can input that into our dose form filter here, and we want single ingredient products, so we can specify IN only here. For the MEPS population, we can put that we want 0 to 5 age range only, and that we do want to target age range, but we don't care about differences in gender or state of residence. So once we have our settings file done, we can execute a simple command to build the actual module. And what MDT does behind the scenes is it calls the Rx class API to get that list of ingredients. It cross-references Rx norm to filter out medications that don't have dose forms in one of these, and that don't have a single ingredient product, which gets rid of a few ingredients. And finally, it cross-references MEPS to find in this population 0% usage of products and gets rid of those ingredients as well. So what we end up with is an actual JSON file, which is a module that is in Cynthia format. We also have lookup tables, CSV files. And so in the module, it also has remarks that shows you the different steps of the process. And the first step is which ingredient a patient gets right here. And we'll see that it lines up with this visualization on the left. So 3% of the population gets beclomethasone, 48% of the population gets budesonide, and 49% of the population gets fluticasone. And that's the first step, is which ingredient to get. Taking fluticasone as an example, we can see that of the 48 or 49% of the population that gets fluticasone, 68% will get this ingredient or this product, 32% will get this other product, and then 0% will get any of these other products because they're not used in the MEPS population based on that survey data. So the final step to integrate this with Cynthia is to replace medication order state with the call submodule state and reference the maintenance inhaler submodule that we created, also putting our CSV files in the appropriate lookup tables folder and our JSON file in the appropriate medications folder. So once we've done this and run Cynthia population, we can see the difference that it creates. What we did to validate the impact of MDT on the diversity of medication orders was to conduct chi-square goodness of fit test on the current state versus the MEPS gold standard, and again on MEPS gold standard versus Cynthia plus MDT, which would be future state. What we can see in current state versus MEPS gold standard is that there is a statistically significant difference, which we would expect based on just the difference we can visually see. When comparing MEPS versus future state, we can see that visually it looks very similar, and after performing the chi-square goodness of fit test, we find no statistical significant difference between these two patient populations. And this type of validation can be done on other patient populations and other disease states, but taking pediatric asthma as an example, you can see fairly easily how a developer could take the information from a clinical guideline, input it into our tool, and output a Cynthia module, which is very representative of a gold standard patient population survey.